Hello and welcome to a new video. This is for pre-algebra using the Math UC homeschool curriculum. We're on lesson 24, which talks about volume of a cylinder. Now, just in case it's been a while since you did volume, I thought we'd actually start off with something a little bit easier. So to find the volume of a rectangular prism, which is the fancy name for something that's basically a box, we just take the length, width, and height and we multiply them together. And this gives us a formula, V equals LWH. Because LW and H are right next to each other, it's implied that we're going to multiply those together. So for this rectangular prism that I have on the screen, it actually doesn't really matter what you count as the length, the width, and the height. It just matters that we have all of the things all the information we need. So in order to figure this out, we would basically do 3 times 4 times 9. And it doesn't have to actually be in that order. We also could include miles, so 3 miles. This is a really big rectangular prism. If we're talking about miles, that's kind of crazy. I didn't think about that before I started this problem. So 3 miles times 4 miles times 9 miles would give us the volume. So you can do this in whatever order is easiest for you. Like I would do 3 times 4 and get 12, and then 12 times 9, which is 108. And then as a reminder, when we do area, our units end up being square units, because area means like how many squares can we actually fit inside something. When we talk about volume, we have cubic units. We say how many cubes will fit inside. So we take this miles and we put a cube after it, so miles to the 3rd power, to show that inside of this rather large rectangular prism, we could fit 108 cubic miles inside it, which is that's a lot of cubic miles, a lot of volume. So that's kind of a base reminder of volume, and that's one way to write our volume formula. But once we start looking at other things that are not rectangular prisms, it's actually helpful to have a different version of this formula. So that version basically says that volume equals the area of the base times the height. And so if we think in this example, if we think of like this as the base of our rectangular prism, it doesn't actually really matter on a rectangular prism what the base is. But if we think of this as the base, then when we did 3 times 4, we found the area of that base. Thinking of it this way gives us a formula for any kind of prism that we would ever encounter and want to find the volume of. So like a triangular prism, this is going to be really good. Like this. If we can find the area of the base, which is this triangle here, then we times that by the height and we get the volume. And then on top of that, we can also make this apply to cylinders. So a cylinder is a 3-dimensional shape that has circles for its bases. So it has a circle on either side, and then in between the circle is basically whatever material wraps around to connect the 2 circles. There's lots of things that we have that end up being cylinders, like cables, I guess, or cords all end up basically being cylinders if you think about it. But like canned food or cans of soda or bottles or anything like that has a basic cylindrical shape. So they're pretty common overall. So, cups, most cups, a lot of cups have like a tilt to them, so they wouldn't be quite the same. But we have cylinders. We encounter them a lot. That's supposed to be the gist of this. So if we apply this idea of if I have something that has basically the same thing on top and bottom, if I can find the area of that thing on top and bottom and times it by the height between those 2 things, it gives me volume, then that gives us a formula to find the volume of a cylinder. Written one way, we would say it's that the volume equals the area of the base times the height, and a lot of times you'll see this capital B to represent area of the base. Or, even better, we know how to find the area of a circle, and cylinders have a circle for the base, so we just put that in to the formula. So this second formula, this is what we're going to use in this lesson, basically. We're going to say volume equals pi times the radius squared times height. That pi times the radius squared is the part where we're finding the area of the circle that's on top or bottom. Then we're going to times it by the height. Now, just occurred to me that I don't know if the Math You See workbook intends for you to do this all by hand or to use a calculator, which I had thought about that a second ago, but I hadn't really thought about the fact that like pi is, you know, we'd have to specify that we're using what pi is 3.14, which makes me think that maybe we should just use a calculator here. So that's gonna be what I'm gonna do. You certainly can do this by hand. It's gonna be annoying to do it by hand, but we could do it by hand if we wanted to. Even without the 3.14 part of this, though, it's going to end up being a little frustrating. Now, let's say that you don't have a calculator, because, you know, not everybody does. What we can do is grab a phone, which has a calculator, although there are some pros and cons to that. Or we could actually use, there's a free calculator that I really like to use that's called Desmos. So let me spell it out for you, Desmos. It has an app that you can download on your phone. It also has a web browser version. So when you start up Desmos, it looks like this, and this is a graphing calculator actually. But if you type things in over here on the side, it will tell you answers. It's not just for graphing, basically. So we'll use this to help us with our calculations here. So example 1, it says find the volume. We've got a radius of 7 centimeters and a height of 5 centimeters. Our formula is V equals pi times the radius squared, the radius is 7, times the height, which is 5 centimeters. So what we need to do is pi times 7 squared times 5. If we're doing this by hand, we'd do 7 squared, which is 49. Then I would recommend doing 49 times 5, which is a big number, and then we'd take that and times it by 3.14. We're going to put this in the calculator. If you're using Desmos, on the computer, you can actually type pi, P-I, or you can pull up this little thing and there's a pi button, and that's going to help you if you're on the phone using it as well. If you are using your phone, I feel like the phone calculator, like iPhone calculator, probably has a pi button. If you're doing things on your phone calculator and you're like, wow, that's not a lot, if you turn it sideways, a lot of other stuff actually pops up. And so let's see, pi is down in the bottom middle, so you can do that. I don't like using the phone calculator as much because it's just not as easy to use. To do 7 squared on Desmos, you can use this button down here, and then you would press a right arrow button to, well, actually, no, you don't have to do that if you did a squared. And then times that by 5. And you could see probably that it just kept updating as I typed more things in. So the volume for this cylinder, we're going to round it to 2 decimal places because that third decimal place is 0, so that seems like a pretty nice place to round it to. Our answer here is 769.69. And our units are going to be centimeters cube or cubic centimeters. And that's kind of the gist of what we're doing. Now, there's a couple things they can give us to throw us off. So that's going to happen to us on example 2 and example 3. On example 2, the issue is take a look at that 14 inches and how there's a line all the way across. That means they gave us the diameter, not the radius. So we have to take the step of saying, if the diameter is 14 inches and that means all the way across, what is the radius, which is halfway across? Now, hopefully it's not too much trouble for you to go, okay, that means the radius is 7 inches. The bigger issue, I think, comes from actually remembering that's what you have to do. This is kind of unfortunate that this is 7 again. That was not my intention, but you know what? It's fine. So 7 inches squared times 8 inches squared, not squared, times pi. This is going good. So let's see. I can delete what I had and write over it, or I can do a new line. I should have actually just gone up and changed the 5 to an 8. That would have been easy. Here, I think I'll round to 1 decimal place because the next place is a 0. So that seems like it makes sense. I didn't see that it specified in the book what to round to. So we don't usually round to the nearest whole number on problems like this. So I would say rounding to 1 or 2 decimal places should be good. So that's our answer right there. Let's look at example 3. So what's different about example 3? It still says find the volume. We've got a radius of 2 feet and a height of 48 inches. But wait, those are not the same type of units. So that would be our first step, is we either need to change the feet to inches or the inches to feet. And in this case, those are equally easy. 12 inches are in a foot. So you could probably change either one, just whichever one you wanted to do. So either we need to change 2 feet to inches, which would be 24 inches. Or you could actually change 48 inches to feet by dividing by 12. I'll go ahead and use inches just for fun. And the problem I used to make this problem, I think they actually specify what they want you to use, which is nice because then you don't have to decide. So for our formula here, we would have pi times the radius, which is 24 inches squared, and times 48 inches. Definitely not one that I would want to do without a calculator. And if you're like, I still don't really understand why we had to make that change. If I had feet still and I square the feet, that gives me feet squared. And then I'd have inches, and I can't combine feet squared and inches together to get feet cubed or inches cubed. And so that's why that's not going to work out. We need our units to match. And that's true just in general. Almost anything we're doing, we need our units to match so that we can actually work it out correctly. So just an FYI sort of thing right there. So let's do this. Pi times 24 squared times 48. Ooh, that's a large number. So this would be 86,858.75. 86,858.75 inches cubed. That'd be our answer. Incidentally, to change this to feet cubed, once we have inches cubed, you actually have to divide by 12, but you actually have to divide by 12 3 times because you're basically dividing by a cubic foot's worth of inches. So in case you were wondering how that works, if we divide this by, nope, that's not it. If we divide this by 12 times 12 times 12, this would end up being 50.27 feet cubed. So that's how that would work. Which is why, by the way, if they tell you what they want you to use, you should probably try to change them to that first and then work out the problem instead of trying to change it later. All right, example 4 is a word problem. We do have a couple word problems at the end of each of these workbook pages. So let's say your water bottle is a cylinder and the radius of the base you measure to be 3 inches. I just realized that's a really, really big base, but it's fine. You have a really large water bottle because you really like being hydrated, as we all do. So the radius is 3 inches, its height is 6 inches. How many cubic inches of water can your bottle hold? So I did not notice anything too terribly difficult in the word problems in this section. Just they're giving it to you with a different set of information. So I suppose the main issue will be making sure you have the radius. If they give you the diameter, you have it. And so then making sure you know which number they're giving you as the radius and which one is the height. Because one of those needs to be squared, the other one does not. So this would be, if we were doing it by hand, 9 times 6 is 54, and then we do 54 times pi. So let's do that. Pi times 54. 169.65 inches cubed. And there we have it. This is finding the volume of a cylinder. In a couple lessons, we're going to do some more volume, which is exciting. And I'll see you hopefully in the next video. Bye.